What do we know about y? What should the formula for y be?
Sine.
Okay, so what should be in front of sine? Remember we did r cosine for x, so now we need to do r sine for y. We got to tell how far to go out too. But it really makes sense and lines up with the unit circle stuff. So this is super easy. If it gives us polar, then literally we just plug into the formula. So to find x, this is our r and this is our theta, isn't it? Okay. So this will be r cosine 5 pi over 3, and y will be r sine theta. Now, thing is that you got a unit circle, not your calculator. If the value is on the unit circle, you need to give it to me in terms of the unit circle. So what is the cosine of 5 pi over 3? 1/2. So this becomes 2 times 1/2. So the x-coordinate is 1. What is the sine of 5 pi over 3? Negative root 3 over 2, isn't it? So the 2's go away, so this is just negative root 3. So the x, y coordinates are 1, negative root 3. That's the answer.
What did you calculate instead of?
Nothing. You're using your unit circle. Now, negative 6, 3 pi over 4. To find x, we do what?
R cosine.
So negative 6 cosine 3 pi over 4. And y is negative 6 sine 3 pi over 4. So this becomes negative 6 times something. This becomes negative 6 times something. You got to fill in the something from your unit circle. What is the cosine of 3 pi over 4?
Negative root 2.
Okay. Negative root 2 over 2. Get your unit circles out. What is the sine of 3 pi over 4?
Root 2 over 2.
Good. Root 2 over 2. So negative 6 times root 2 over 2. So
Oh, I got it.
negative times negative is a positive. 2 goes into 6. So this is 3 root 2. And this is negative 3 root 2. So my coordinates are 3 root 2, negative 3 root 2. We're going to do one more of these that's got a negative, and then I'm going to make you try one on your own. With your unit circle, we really need this to be positive, don't we? So how do I change negative pi over 2 to a positive? What do I add to it? 2 pi, right? 2 pi is the same as what? So what does this actually become?
3 pi over 2. Can
So-
you do like that flip thing that you taught us?
Yeah. So now this is negative 1/4, 3 pi over 2. Please find your x and your y. Set it up and find it. Yes. You're going to have to.
Because I got mine from notes.
No, you just use your unit circle that you have. Nope.
It's too late already.
All right, so try number 4 on your own, and then we are going to move on to the next part. We just did polar to rectangular, so guess what? Now we're going to go the other direction. So do number 4. Now, Carlos, do you see number 5 and number 6 where those aren't values that are on the unit circle? If the values aren't on the unit circle, then what do you get to use? Your calculator. If it's got a degree mark next to it, you make sure your calculator's in degrees. If it's got a pi with it, you make sure you're in radians. No, I'm just giving you the answers in case you want to try them later. To make sure you know how to use your calculator in radians and in degrees. Did everybody get the answer for number 4?
So with the one that's like with 7 over 2,
Uh-huh.
would it be kind of wrong if I read this number? Like,
Negative 3.5? No? That's fine, as long as it can be decimal as long as it's exact. All right, so are we good on this?
yes.
Now, rectangular to polar has to do with this. Remember, if we are going to some location out here, this is R and this is theta, isn't it? Well, guess what? This thing is a right triangle, isn't it? So this is X and this is Y. So if we're given x and y, we can find r and theta using the Pythagorean theorem and some trig. The Pythagorean theorem gives us r. In a right triangle, wouldn't it be a squared plus b squared equals c squared? Well, this is our c, and this is our a, and this is our b. So what we get here is we get this. We get r is equal to the square root of x squared plus y squared. Now, the x and y over here, guys, this x and this y, with this angle theta, this is opposite and this is adjacent, isn't it? Which trig function is opposite over adjacent? Tangent. So we can find theta by doing the inverse of tangent. Not cotangent. Inverse tangent. Tan negative 1 of what? Opposite would be y. Adjacent would be x, wouldn't it? All right, so this is x and this is y. Let's find our things using the formulas. So for r, we're going to do the square root of 2 squared plus 2 root 3 squared, which is 4 plus 4 times 3, which is 12. So this is the square root of 16, which is 4. So my r is 4. Now theta is going to be the inverse tangent of y over x. Now, that gives me the inverse tangent of root 3. Remember, tangent, guys, first things first is you got to figure out what gives me tangent, what quadrant am I in? Because that's going to make a difference as to where your angle is, won't it? So what quadrant is positive, positive? Quadrant 1. So where is tangent root 3 in quadrant 1? Yeah. So this is pi over 3. So my formula right here is going to be 4 pi over 3. Now it says give 2 possible solutions. Yeah, you already got your unit circle out though, don't you? What's directly across from pi over 3? 4 pi over 3, isn't it? So, or 4 pi over 3. And if we go directly across, what happens to the 4? So C, super easy. Nope. This one's simple. You just go straight across and change the sign. All right, 3 root 2 over 2, negative 3 root 2 over 2 is which quadrant? Let's do one more of these. X is positive, y is negative. Quadrant 4. I know. So r is equal to 3 root 2 over 2 squared plus negative 3 root 2 over 2 squared so that would be 9 times 2 is what? 18 divided by 4. So this would be square root of 18 over 4 plus square root is the same thing, isn't it, squared? So 18 over 4. So this is the square root of 36 over 4, which is root 9, which is what? 3. So yeah, 6 over 2, which would still be 3. How your brain works, you'll get the same answer. Theta is the inverse tangent of negative root 3 over 2, 3 root 2 over 2 divided by 3 root 2 over 2. So that's the same as taking the inverse tangent of what?
-1.
All right, so where in the fourth quadrant is tangent -1? So this is going to be 3, 7 pi over 4, or -3 what? Yes. How did she get 3 pi over 4? Straight across. Straight across, change the R. Change the sign on the R. See, it's formulaic, isn't it? You just plug it in the formula using your unit circle. You can do this. Please try number 10. Figure out what quadrant you're in. What quadrant? Quadrant what? Yeah. X is negative, Y is positive, so quadrant 2. So now figure out your R. Leave it in simplest radical form, please. That means if there's a square root that doesn't end up being a perfect square, reduce it to where it is as close to a perfect square as you can. Did you get the 2? Remember, you got to take into account when you're doing the inverse tangent of which quadrant it's in, don't you? All right. So do we all feel fairly secure in what you've learned so far today? You can convert from polar to rectangular and from rectangular to polar, back and forth. Good. That's coordinates. Now we're going to do the same thing for equations. Okay? Same thing for equations. If you take it, here we go. The big things you need to remember, these are easy, is x is our cosine and y is our sine. Same thing we just learned, isn't it? So everywhere there's an x, we are going to plug in an r cosine. Everywhere there is a y, we are going to plug in an r cosine. So this x becomes what? And then we are going to solve for r. So if I'm going to solve for r, what do I need to do? Divide by cosine. So this is the same as negative 3 times 1 over cosine. So this is negative 3 what? Yeah, what's 1 over cosine? Secant. You want, the idea is you want it to look like those things that we graphed this last time, don't you? Isn't this what one of those formulas look like? Okay. I convert, I plug in, and I solve for r. Now, what about the next one? I have a y. What do I put in for y? I put in r sine. And for x, as a matter of fact, you know what? I'm going to cross multiply and put a 3 over here. Is that okay with everyone? Yes? Okay, just make it easier. So now I've got root 3 here, and then I've got x, which is what? R cosine. Now look what I have on both sides here. What can go away? It doesn't really matter. Now, the r went away, so now I just got to get the thetas all on one side. So which side do you want the thetas on? If we're solving for it, we want it on the left, don't we? So if I want it on the left, what do I need to divide both sides by? Cosine, yes. Cosine, divide by cosine. So 3. Sine over cosine is what? Yes. And now I want tangent by itself, so just divide by. And I have an answer. Now the cool thing is I actually know what that is. Where is tangent? So theta is, and that's actually a better answer. And yes, you do need to move it if you can. All right. Unit.
Yeah.
Sure. All right. Y equals x squared. Plug in for y. What do we plug in for y? And what do we plug in for x? But we have to square it, don't we? So this is r sine, but this is r squared cosine squared, isn't it? And now we got to get r by itself, don't we? So first things first is what can we do about, we got an r on one side and an r squared on the other side. What can we do? Divide by r. That goes away, and that goes away, doesn't it? So now we've got sine theta equals r cosine squared. Now how do I get r by itself? Don't say. Oh, how did I get that?
Why? Is this all playing into each other? No, I understand because
It is.
sine over cosine is tangent. And you have cosine in the denominator.
Yes, you got it. Sine over cosine times 1 over cosine, right? Okay, let's try one more. This one ought to be pretty easy. X squared plus y squared equals 16. Guys, somebody just tell me what that is. Thank you. It's a circle. If it's a circle, it should just end up being r equals something, shouldn't it? Think about what we just did last time where we were graphing. Remember, anything that's just r only is a circle. So this will end up just being r equals something. So how do we get there? What is x? So we end up with r squared cosine squared. And y squared becomes what? What do both of those have in common? Both of those terms have in common? Ooh, so if we pull an r squared out, what are we left with inside? Oh. And what is sine squared plus cosine squared? 1.
Right. Oh, so it is 4.
That's what I said.
Yes.
Yes, that's what he said. Do it. Right. Oh, it is 4.
Yeah, because we know the radius of this would be 4, wouldn't it? So you could have just skipped right to boom, radius 4. Now be careful though, because you're going to think this one is a circle in number 6, and it is not. It is not x squared plus y squared, is it? If you move it over to the other side, it's going to be x squared minus y squared, so it doesn't end up that way. All right, back here, and you look at some of these, like this guy, if this one had a plus or a minus 1 next to it, or if the x had a plus or minus 1 next to it, you know it would have to be you would know it would have to be what? Either sine or cosine, right?
Right.
If the x has it, it's going to be cosine because it's going to move it this way or that way. If the sine has it, the y has it, you know it's going to be sine because it's going to be either up or down, right? Okay. Let's look at the last section that we've got. Now this is a circle, so I'll end up with r something, but we're going to look at polar to rectangular. Okay. Polar to rectangular. It says recall the following. R cosine is x. R sine is y. R squared is x squared plus y squared. And y over x is tangent. So guys, guess what we need to have? We either need to have an r cosine to replace, an r sine to replace, an r squared, or a tangent. So right off the bat, look what happened. We don't have any of those, do we? We got r. But what could we have? R squared. So what do we need to do to both sides? So now we have r squared equals what?
49.
And what can I replace r squared with?
X squared plus y squared.
Mm-hmm. And boom.
Wait, that's it?
Now,
So we need to remember all of this, like everything that was in bold right there.
those are what you're going to use. I will give you the formulas for these because that I don't care about. That's fine. You just need to know how to use them.
If we were to do what we had just did on the last page to the answer, it would take us back to R7.
Yep. Now, theta. We don't just have a theta up here, do we? But what's the closest we have to just theta? Tan. So what do I need to apply to both sides here? Tan. Tan. So now I have tan theta equals the tangent of 2 pi over 3. Don't I know what the tangent of 2 pi over 3 is?
Yes.
So what is the tangent of 2 pi over 3?
Negative root 3.
So negative root 3 on this side, that comes from the unit circle, doesn't it? And what can we replace tan theta with from our list up there? Y over x. And now we can just cross multiply and get y by itself, can't we? So what is y equal to? I just cross multiplied it over, right? Times x times x. Let's try another one. So if we don't have it, we got to make it. All right. So this is kind of fun. Secant isn't even in the book, is it? So let's rewrite secant first so we can see if we can figure out what to do. What is secant? 1 over cosine. How do I get rid of a 1 over cosine? Because I multiply both sides by what? Oh, hey. So now what do I have? R cosine equals, oh, check my list up there. What do you notice? And what is R cosine theta the same as? X. So X equals, boop. Now you guys try it with number 12 and see if you can get that.
So I got a question.
Yeah?
So remember to say my field is wall break.
Because we typically solve just for y, unless it's a particular equation that we recognize. Like that guy, that first guy, why we left it at x squared plus y squared, because we know that looks like a circle, don't we? However, the other one, theta is a line, isn't it? Just theta is a line, so don't we want to write it so it's recognizable as a line? That would be y equals mx plus b. Secant is also a line, isn't it? Matter of fact, secant is a line, x equals 3. That would be this way, wouldn't it? So x equals 3. You got y equals what? Yep. Y equals -2 is correct for that one. So we write it so it's recognizable as what it should be in its polar form. All right, so let's do one more tough one, and then we're done. Let's look at one of these. R equals 2 sine theta. This one you can't just multiply. We don't have just sine theta. We don't have just R. But look up. We've got sine theta. But what do we need sine theta to be? To replace it. What are we missing in front of it that we need? So maybe we need to multiply both sides by R. So we're going to multiply this side by R and this side by R, which is going to give me R squared here and 2R sine theta. Now this actually works out pretty well because we can replace R squared, can't we? Look at your list up at the top. What does R squared get replaced with? And what does R sine theta get replaced with? So now we've got to actually take this and put it into something that we know what it's supposed to look like. This is supposed to look like a circle, isn't it? That's been moved. As a matter of fact, it's a circle. R 2 sine theta would be above, wouldn't it? From 0 up to 2, so the center would be at 1, wouldn't it? So it would be 0, 1. So let's do this. So what we're going to do is move this over to the other side. X squared plus y squared minus 2y equals 0. And do you know why I left a space there? To get this in the form of a circle, we need to complete the square. This is a great review. How do we complete the square? We take the b, half the b term, so half of -2. Half of -2 is what? So half of the middle term is -1. -1 squared is 1. So we put a 1 right there. So plus 1, right? And if we put a plus 1 there, what do we also need to do the other side? Plus 1 there. We completed the square. So now this becomes x squared plus y minus 1 squared equals 1. And tell me, isn't this a circle whose center is at 0, 1, whose radius is 1, isn't it? And if we graph that guy, that first guy up there, if we graph this guy, he starts at 0, and he goes from 0 up 2, so it puts his center at 1, and it puts its radius at 1. Center at 1, radius 1. This is this. So see how it works out. So if you know those shapes, this should help reinforce what those shapes all should look like. Okay? So you can get it. Same thing goes going the other direction. You need to finish all your homework up for next time. I'm going to be checking 3 assignments next time. 3. The complex number review, right? The one that you were supposed to have done from this time that we spent some time going back over. That is homework 1. And then this one, which is homework 4. I will even take pity on you and tell you just to hold on to the ACT question, and we'll just do it next time in class. Okay?
Oh, I found it.
Wait.
Last one.
It's homework
She
5.
said she checking 3 assignments.
Mm-hmm.
This homework, the homework
Is
from last
it
class.
homework and stuff?
And then the one from the time before that. Yep.